So, I welcome you all for the NPTEL course on subsurface exploration, importance, and techniques involved. So, myself, C. Sandhya. I'm a research scholar at IIT Madras. I'm doing my research on geotechnical engineering. So, I did my MTech in soil mechanics and foundation engineering at Anna University, Chennai. I joined for the PhD in 2020, and I'm a PMR of Scholar. That is a Prime Minister Research Fellowship awarded by the MHRD for only a few types of or a very specified selected researchers. So I am one of them. As a part of the PMRF, we are entitled to do TA work in a college or in NPTEL. So I'm happy to do this TA duty for subsurface exploration. So from your side, what I expect is you have to go through the week video. The week now we are going in for this is the first week. I believe that you have gone through the week one video. So in during this 1 hour, I will be handling some questions related to that particular week, and also the questions will be related to the subject, and also it will be some of the questions will be from the competitive exams kind in that way. Okay. Only if you I will be also touching upon certain important aspects of that week, some important points or important topics of that week, but I won't be going much deeper. Okay, only if you have gone through that video, you'll be able to understand what is going in this 1 hour. Okay. So since it's the first class, I may not I'm not sure whether you have gone through, but for the next coming weeks. Okay, so now week 2 has been uploaded, so please go through the week 2 before coming for our next Tuesday. So every Tuesday this class will be between 6 to 7. We can have some discussions during this session. If you have any doubts or if with respect to specific topic, I'll sure try to clarify it to you. Okay, so subsurface exploration. Why do we need to study this course, and what is the importance of it? I'll just have a small intro. See, any structure that is going to be built on this earth is going to transfer the load ultimately to the soil. Okay, so soil is the one which is going to carry the load from the superstructure that is being transferred from the slab to beam, beam to column, column to foundation, and finally to the soil. In situations like this where we have interaction between the structure and the soil, you can see when the load is being applied on the soil will try to resist it. Okay, so this resistance is what helps in carrying it. If it's not resisting, then ultimately this structure will be going below. In structures like this buildings, we have interaction between the structure and the soil, whereas in constructions like pavement or earthen embankment kind of thing, so the load from the soil is being transferred to the soil. Okay, so there we will have a soil to soil interaction. So when the load is being transferred to the underground, which can be soil or it can be a rock, okay, anything, we have to know what type of soil or what type of rock or what is present below this earth, in order to have the safety, in order to ensure the safety of the structure that is being built. So a soil, ultimately soil will be failed by shear. You can see a part of the soil has moved away from the remaining portion. Okay, so it can fail by shear or it can fail by settlement. So settlement means once a soil goes down due to the load applied because of consolidation, or because of the removal of the water from the soil, so ultimately the soil settles, and you'll be having crack. Okay, so this settlement is limited for each type of structure. When the settlement is beyond the uh, uh, beyond the beyond our guidelines. Okay, so then we term that the soil is failed, or there will be, because of that settlement will be having lot of cracks in our structure, and the structure serviceability will be the structure will not be used further. Okay, so these are three types of shear failure in a shallow foundation. That may be like general shear failure, local failure, or punching failure. Okay, so what I try to tell is the soil is going to fail because of the, if you're not assessing the properties of soil properly. Okay, this failure is going to be catastrophic. So once the soil is going to fail, it is going to cause us loss of life of human or the any other living being, or and also it is going to cause you economic losses. So we have to be very sure before constructing any structure over a soil, whether that soil will be able to withstand that load. That we have to make sure. For that, we have to do a site investigation. So we usually tell site investigation is like going to a doctor. So imagine if you are going to a doctor for just an headache or a stomach pain or anything, fever. Okay, we expect that the doctor will be checking at least our bp, our pulse rate. Okay, so then he will be giving a medicine. Imagine what if the doctor, without checking anything, you are just telling you are having a fever, he is writing you CT scan or a X-ray or ECG. Okay, so then we'll have a bad opinion about the doctor. So like that, when we propose a site for a construction, we have to know what could be the possible problems also that may occur in that site if once a construction starts. Okay, whether constructing in that particular site is going to be economic, safer, and also it is going to be it's going to withstand for a longer time. All those things we have to analyze. So can anyone tell what could be this picture? By seeing the picture, by seeing it tilted, can anyone guess what could be what could be this building? Yes. See, let us keep this interactive. Okay, so what could be this
Ma'am, we
building?
can't see the presentation.
My goodness, you should have told me that. I'm so sorry, sorry, sorry. Sorry, since it's a first class, I have missed few things. Sorry. Thank God I have asked that question. Okay, so are you able to see now? Is it visible? Yes. Is it visible?
Yes, yes.
Yes. Thank you. Thank you. Yeah. So I was talking about this load transfer. Okay. Then these are the failures that may occur in a soil. It can be shear failure or it can be a settlement. Okay. So now we are in this picture. Okay. Yeah. Now can anyone tell what could be this structure? What structure this could be? Name of the structure? It is it is tilted in one side. I can give you a clue. Can anyone tell the name? It's a famous wonders of the world. By this time you should have known. Yes, you can give it in the chat box also if you are not able to tell. Okay, what structure is this?
Taj Mahal.
Huh? It's tilted. I gave you a clue. It's tilted. Taj Mahal is not tilted yet. This is famous because it is tilted and it is able to withstand till now.
Is it Leaning Tower of Pisa, ma'am?
Yeah, thank you. So this is the Leaning Tower of Pisa. Okay, so if even though we have lot of structures which is not tilted, which is strong, which is standing up straight, this is famous because it is tilted and it is yet not fallen. So now since it has become the wonders of the world, people are trying and spending lot of money to in order to make it help it without falling. Okay, so if you just free, you can go through how much millions of dollars are being spent in and what are the measures they are taking. So if you see what is lying below this Leaning Tower of Pisa, you can see it is a clay, and you have lower clay, lower sand here at a larger depth, and here you have groundwater level because of the sea, because of the groundwater level at a shallow foundation, and you have sandy and clay soil here. This stratum has become very weak. Okay, they have not done any proper site investigation, and without doing proper site investigation, without analyzing whether this strata, this ground will be able to withstand, they have constructed it. And now, because of the settlement, we call this as a differential settlement. This layer is settling at a higher value than than this site. Okay, so what they are doing, they are applying counterweights here so that it can come, it can little bit, it can withstand in this portion. Okay, such measures are made. Okay, this we don't want to happen in our structure that is being built. Yeah, since it is a monument or a kind of old structure, it is tilted, people are okay with it. Imagine if you have a nuclear power plant or any bridges. Okay, what is if it is tilted? Okay, then they are going to immediately take actions on us. So we have to analyze what is that lying below the earth. That is, what is the subsoil type, what is the strength, what could be its index properties, and what is the groundwater level. These are the major or main thing that we see in a report. Just like in a blood test report, they see for your RBC count, they see what is your platelet, what is your WBC, such things. Okay, blood test is very very important in order to analyze whether you are in a good health or in a bad health, or how, or you are in border, or whether it is possible to improve your health, or you are in the worst condition of your health. Such things we are able to analyze from a blood report. So similarly, from a soil test report, we will be able to analyze whether we can improve it, or whether we have to abandon that site, or whether we have to design our foundation. Obviously we have to design our foundation at least according to the site condition. When we are going to excavate, what if there is going to be a sudden ingress of water into the site? How do we face that? And I also will show you some pictures here. This is a excavation. See, this is excavation being carried out, and you can see here the soil has moved laterally in this direction. So it is a tendency of the soil to move towards the open space. Okay, so once you remove a soil, when once you excavate, okay, we can see in daily newspapers many people have died in mines or etc because of soil sliding. So landsliding, that is natural, that is we don't have a control over it. Whereas when we do a excavation, it is a tendency of the soil to move towards that excavation open area. So because of that, there is a failure. And also, this is a famous failure, highway failure at Singapore. They have a, you can see this is before failure. They have a shaft here. Okay, they have a shaft, and this is kind of what is that, struts given to protect the sides. Okay, yes, they have designed the struts, they have tried to resist the movement of the soil inside. But what has happened? Suddenly there is a failure of the struts, and there is a failure of this highway. This is a very famous highway failure of Singapore. um, you can imagine what could be the effects of all these failures. Even though we have analyzed the soil, yes, they have analyzed the soil, they have provided the struts, but this has happened. This means that there is poor attention to detail. Okay, there is a paper, journal paper on this topic. They have given, like, it's a forensic even soil investigation. It is not that it is done only during or before the construction. It is also done in terms of forensic. If there is going to be a dam failure, or if there is going to be any failure like this in a highway or a bridge failure, then that time also they will be conducting soil investigation, and they will analyze what has gone wrong, where the mistake has happened, whether the mistake is with the structural design, or with the mistake is whether they have not properly analyzed the site condition, or there is going to be some natural issues, whether there could be sudden water seepage into the site which they would have not expected because of the ground level increase in the surrounding. Okay, so all those assessment will be carried out only by doing a proper soil site investigation. So Why to do a site investigation? As I said, the first step is going to we are going to determine what is the nature of subsurface medium. Below the ground there can be anything. There can be rock, there could be sand, there could be clay, there could be silt, there could be saturated soil, groundwater table. And also, if I tell rock, it is not a single rock. It does not mean that rock is going to have a very good strength everywhere. It can be a weathered rock. Okay, so anything, because this while this earth is being formed for millions of years, we don't know the place where we are living in would have been below sea for before some hundreds or thousands of years ago. Okay, so this formation of the natural material below earth, to assess that is very very difficult and a challenging issue. Not like anything like cement, concrete, or steel. Okay, if you are going to test steel, it's a manufactured material. It's going to have the same property plus or minus throughout the world. If you are going to tell it's Fe4 and 5, it is Fe4 and 5. It is going to give you the same strength everywhere. It's M25 concrete, means if you are going to mix in that ratio, you are going to get it M25 concrete. But with when you deal with natural material like soil, the challenge is very huge, and this area is having a very big scope. Okay, so when and the depth of strata. Okay, so okay, I'm going to assess the soil, and we are going to find out the nature of soil is going to be clay. Then the question comes, to what depth or what thickness that clay stratum is existing. So you have to find what is the thickness of the various substrata, and in lateral direction also how they are spreading. Okay, you may have below your house, you may have a rock, and after some 2 meters there will be no rock. There will be full of soft soil also. Anything is possible. Okay, so we cannot judge the stratum that is lying below ground without easily. So next comes the depth of groundwater table and its fluctuation. Very very important is assessing the groundwater table, because the soil gets failed, or the failure of is highly contributed by this water seepage. If water and soil has no reaction, then there would be no need necessary for soil mechanics, which is a branch. Okay, so the groundwater table and its possible fluctuation during summer and winter season, how what could be their depth below the surface, that is very much important. Next is going to be underground seepage or erosion. So when we do a deeper excavation, even now we when we go for skyscrapers or G+20 etc., we go for 3 floors below for a parking itself. Okay, so the when we do a deeper excavation, we have to see that if there is going to be any seepage or erosion issues. This also occurs in bridges, especially in bridges. Okay, so there are case studies where because of continuous erosion, the bridge piers have undergone, or foundation has been exposed. Okay, so that thing we have to see. And we have to see what is the composition of groundwater. Yes, nowadays the groundwater may become contaminated because of any leachate percolation, or there could be some dump yards nearby, which can be any hazardous dump yards or anything. Okay, so we have to see whether the groundwater that's flowing in is having any contamination. Next, the strength characteristics. So okay, you are having clay below or a rock, you have to see what could be the bearing capacity or what could be the strength of that layer, because once you're going to load it, that soil should not undergo a failure. So you have to determine what is the resistance that layer could offer to your structure. See, initially, when we propose, for example, for a very important structure like a nuclear reactor or airport, dams, etc., we usually have some 10 sites, at least some 10 sites in mind, wherever we want to uh, construct. Okay, so we have to perform this site investigation. We have to see what could be the then comes the money. Okay, so how much money would be involved in construction. So certain location may require a pile foundation, so which is a deeper foundation. Some location may require a shallow foundation for that particular project. If you see, the cost involved in pile foundation is going to be huge. whereas a shallow foundation it's going to be very less. So that strength characteristics we have to analyze. Next comes what could be the possible challenge that may arise during the construction, and we have to be prepared for any remedial measures. We may have thought of we may would have thought there could be perfect rock, okay, but suddenly there could be a highly weathered rock, or there could be seepage from the sides, there could be a lake far away because of sudden rain, or because of that there could be water seepage into the site. So once water is getting seeped through, suddenly your sites may get eroded, there could be failure happening. Yeah, there could be quicksand conditions occurring. Imagine quicksand conditions means where you have a flowing of water from the bottom. So from the bottom there could be artesian pressure that from the site, and also there could be some utilities pipes. What you suddenly damage a gas pipeline or a petrol line that goes through utility lines mains that goes through your site, you don't know. Okay, so only we have to be prepared. What could be the possible issues that may come? What may happen also, if once you construct, there could be a nearby building which has undergone a crack because of your construction, because of the lateral movement of the soil below their foundation, there could be crack in their building. Okay, so we have to uh, be prepared in the report. What could be the issues that may arise when you construct? What could be the remedial solutions also that you may take to provide solution in case of distress, and to ensure the safety of adjoining structures? All these are said now. Identification of problematic medium at site of interest, which is to be given due importance. So in your site, if you face a expansive soil or a swelling clay, okay, so soil may which will swell on absorption of water, and it may crack on desiccation, crack on drying. If you have such problematic soil in your site, excuse me, we have to think whether we can remove that soil, or whether we can add some stabilizers agent to the soil. Okay, if you are going to construct over the soil, soon you will have a undulation because of the moisture variations and fluctuations. So we have to see if any other problematic medium cavities may be present in your site. There could be, see, nowadays sometimes we have a reclaimed site, we have wells. Okay, so what the owner would have done, he have closed the well, and he would have put the site for sale. You won't be knowing there was a well before some 50 years. Then once you start your construction, there could be a sudden subsidence of the ground, because the well, in the well there could be made up soil, it's not a natural soil. Okay, so suddenly we say that if the subsidence is going to be there, then your building will settle, your building will fail. Okay, so you have to be identify what if there is any problematic issues at the site. In case of, excuse me, okay, if you have any questions, please post it in the chat box. Okay. And in case of rock medium, okay, if you are going to have rock medium, it can be used as a construction material. Extent of excavation, its depth and strength characteristics are to be known. It is very, very tough to drill in a rock. Okay, so when you are going to have a rock medium, you have to assess its strength. What could be the type of the rock? What could be the type of weathering or extent of weathering? That rock might be in the stage of becoming a soil. Okay, so you know the geological cycle. So soil comes from weathering of the rock. So you have to know what could be the extent of weathering in that rock, and what could be the depth we can excavate in that particular site. All such things. So codal provisions, it is very important to remember the numbers, because these are the important codal provisions for depth of exploration, which gives you guidelines for depth of exploration, spacing of borehole, and spacing. um, See, once you want to collect a soil sample from a site. Okay, so depending on your site type and and the type of project, there are certain codal provisions which gives you guidelines to go in. The guidelines are again, it's a guideline. Okay, it can be varied. The guideline can tell you you need a four borehole to collect a sample from the site. But if all the soil sample for all the samples from the four borehole are going to be entirely different, then you have to go for a fifth borehole. Okay, it doesn't mean that you shouldn't go for a fifth borehole, since the guideline has set only four. And also, if you are having three boreholes of same soil, or yeah, if you are able to encounter the same strata in three borehole, of course you can stop it in three borehole. No need for the fourth one. So all these guidelines are subjected to the judgment of the experienced engineer. So IS 1892 1979 for multi-story buildings, and IS 6955 1973 for dams, 4651 1974 for the case of ports and harbors, 5878 1972 for tunnels. I'll tell you one easy method to remember these numbers. Actually, when you are about to learn any number, okay, you have to, it's a mind game. Okay, just you have to make that number in the form of a story, and then we have to remember. I will just tell you for one codal provision. You try to make your own story for all the other three so that you remember. So 5878. Okay, so you imagine this 8 5878 is in the form of a tunnel. Okay, you have 2 8 and tunnel as a 2n. Okay, so if they give this codal number, you will be able to tell tunnel. Okay, at least that way you have to remember. So 5878 as 28, tunnel as 2n. So if we find 5 and 8 is in the form of a tunnel, you can see. Okay, so it's like a tunnel kind of thing. So for like, it's like a story. If you remember, you will be able to it's it if you will be able to identify which codal that comes for that project. Okay, so something like that. So then IAEA for nuclear power plants, and then for RDSO 2007 embankment of heavy axle loads in case of railways, and this 6935 is for water table in borehole. Okay, so now you are going to tell me, uh, so for dams. So this is a codal provision. This is how the codal will give you the guideline. For dams less than 30-meter in height, the exploration by pits are spacing of 250-meter to 300-meter. So if your dam height is going to be less than 30-meter, then you have to collect sample. Okay, or by pit method, or there are different method of collection sample that we'll be seeing. So you have to collect sample at a spacing of 250-meter to 300-meter. So for every 300-meter, you have to collect the sample. Depending upon the nature of foundation material may be necessary. So this is how your guideline will be proposed. Okay, so you have choice of methods, depth of exploration, all those details will be given in the guideline. So, phases of investigation. Okay, you are going to do soil investigation. You have a project. The project, let us keep it as a dam. Okay, they are going to construct a dam in our area. So, what could be the two phases of these are the two phases of investigation. One is the preliminary investigation. The other one is a detailed investigation. If we have some 10 locations, we cannot go and collect the sample of 10 locations, analyze what is being present below the 10 locations, because collection of sample is itself not a easy thing. Okay, so you will be doing lot of expenses for the collection of sample itself. So you have 10 locations, it is not possible to go and collect the samples in all the locations and find out whether each site will be useful for the construction of that particular dam. So the first stage is going to be the preliminary investigation. In the preliminary investigation itself, you have to analyze out of those 10 sites, which could be the most feasible, economical, or better locations. Like we'll sort it out, we'll bring down to some two or three sites. Okay, so we'll be cutting out the other sites in our preliminary investigation itself. So the preliminary investigation will be carried out in three stages. If you have seen the video, can anyone tell me any one of the preliminary investigation name? There are three preliminary investigation. Yes. Can anyone tell only one name at least in preliminary investigation? So imagine you are going to be a site engineer. Okay, you have some 10 sites. They are telling that we are going to build a dam. What would be the first uh, step, or what could be the first thing that you would like to know about that site, about all the 10 sites?
Steps involved are reconnaissance. One is reconnaissance.
Okay, reconnaissance, and the next one is study of maps, and the other one is aerial photograph. Okay, these are the three stages. See, I know you are all from different parts of the country, I believe. They are going to give you some exam center for this course. You are going to write the exam for this NPTEL course in your area. They are going to tell some area. Let us keep it as Chennai. Okay, my area. There is going to be the center. What you will do first? Now they give you the hall ticket. Chennai is your location for writing the exam. What you will do first? Yes, study of maps. Inquire about the area. Okay, very good. Thank you. So you will be first look the map. Okay, you will see from your location where is Chennai, how much distance it is, what could be the possible methods to reach, whether it's which is whether the possible modes could be a aeroplane or a train, or it can be a bus if you are nearby. Okay, you will see a map first. That there is a first thing, you see a map where it is located. Okay, so what could be the possible methods to reach it, then you see which is economical method, whether to go by train or whether it can you can go by flight. Okay, economical, and also you will see how long to reach. Okay, in flight it takes 1 hour or 2 hour, in train it takes 2 days. Okay, so it depends on your comfort. Okay, so you'll be coming to Chennai, or before coming to Chennai, what you will do, you'll arrange some stay here. Yeah, you'll book some hotel. Okay, where you can stay. You'll see from your stay where is that exam center. You cannot directly go to your exam center and put your bags and get ready, right? So all these things, we from in our practical life, what we do, the same thing happens in a big project also. So, in a preliminary investigation, when they suggest some 10 sites for construction of nuclear power plant or a dam or a airport or any structure, build yeah, bridge or anything, or a flyover. Okay, so what they will do? They will initially study the map. So where that is located, what could be the possible, if you are going to locate it outer, then your transportation charges for bringing the materials to that site, bringing the labor, everything is going to take time. All those things will be preliminary investigation is very very important before you go into a detailed investigation. Okay, because this only can cut down the cost. You have to collect the maximum details from the preliminary investigation, in which topography it is, whether imagine if it is in Himalayas. Okay, the 3 kilometers in a normal terrain and 3 kilometers in Himalayas is different. Okay, the energy and the time that you are going to spend is going to be in reaching that point is going to be different, the terrain. So topography, what could be the vegetation, what could be the drainage pattern. Imagine your site, you are building your house, and that is located in a low lying area, and once it rains, all the water surrounding is going to come into your house. Okay, then how will it be? So we have to study the drainage pattern of that area, when the rain or when there is going to be a flood. Okay, where the water is going to go. So your preliminary investigation is very very important in terms of reconnaissance and study of maps, and we are going to do aerial photographs. So study of maps, we have lot of maps available, prepared by the Geologic Survey of India and Central Water Board, and there are lot of government bodies which have uh, determined or which have given this map. So this is a generalized geological map of South India. So this will tell you abruptly what could be the expected substrata in your site, in the site that you are looking at. Okay, so this is a geological map of South India given by Geological Survey of India. So like this, we have geomorphology maps, and we have If it is going to be seismic zone, okay, we have a nuclear power plant in a seismic zone, which is going to be very challenging. It can be in a area of tsunami. Okay, so in Ukraine, yes, a nuclear power plant was located in the uh, place where it got hit by the tsunami. So there could be continuous radiation emitted from the damaged plant. Okay, so it is very very important when we carry out this preliminary investigation or a detailed investigation. This is exactly like a work of a doctor. Okay, there are a lot of disease, there are a lot of issues in a human. Each human is different. Each health, age wise, everybody is different, right? Likewise only the nature also. So he will be studying all those reports, and he will be analyzing, and finally he will tell you, okay, you have this issue. Again, when we find a issue, it can be sorted out in another different ways. It can be treated by without an operation, it can be treated with medicines, or it can be treated with any other means. Okay, so there are like just like doctor, how we treat us, it is like we treat the soil. So in a preliminary investigation, we'll be collecting maximum information. Then after, when we finalize the site, okay, this is the these are the two sites where I'm going to build. Okay, then we conduct the detailed investigation. That is where we go and collect the soil sample or a rock sample. Okay, so this is how the soil sample or rock sample will be collected. These are disturbed sample. Okay, so then there comes another type of classification: undisturbed and disturbed sample. We'll see that later. So just we will be collecting samples, just they collect blood samples from us. They will be collecting our stem cells or our pus cells, everything they collect, okay, in order to assess our uh, disease. So like that, we collect the soil samples, rock samples from the underground, and we will assess the site. So detailed investigation will be carried out. So we'll see some questions, okay, and we'll try to find out the answer for that. Okay, even if you are going to answer, it's okay, or if not possible, it's okay, because but next time or next class onwards, I'll be expecting the answer, because all these are from direct questions from the lecture materials. So study in the form of a field trip to the site, which can give information about topography, geology, drainage pattern, vegetation, and land use for subsurface investigation, is known as. Can anyone tell the answer?
Preliminary investigation.
Okay, but the exact answer is going to be reconnaissance. Why it is? Preliminary investigation is a common term in which reconnaissance, study of maps, and aerial photographs are going to come. So in reconnaissance only, we will be doing this. This is the exact uh, closer definition or closer work that we do in a reconnaissance survey. Okay, so where we go to the field, we see the field, and we gather lot of information from the field without doing any test. We have to see whether if there is going to be any electrical lines running, whether any electrical towers are being present. Okay, all such information that we do a field visit. We are not going to get any sample. Okay, we are directly by seeing the site, whether it is located in a hilly area or in a low level area, whether there is any bedrock visible from that, or whether there is what could be the flow of water pattern, drainage pattern in that. We visit the nearby building. If luckily if your site is nearby having surrounding buildings, so which is having all g plus 10 and etc, more or less that gives us information. Okay, this site which I am going to build is will be able to withstand much load, because the surrounding buildings are able to withstand, okay, that much load. So we'll be seeing what are the types of buildings that is around our area. What is the vegetation? Why do we need a vegetation? Can anyone tell? Why do we need, what type of vegetation is there? What type of plant or trees are there? So the vegetation will give you some rough idea about the groundwater table and the type of soil in that area. See, if you are going to have a lot of eucalyptus present in a site, it is going to absorb lot of groundwater or water in that area. Okay, so that means that the groundwater may be very much below. And also there are certain vegetation which grows only in soil. We have a black cotton soil, we term that as a black cotton soil. What does it mean? It is very good for growing black cotton. Sorry, it is very good for growing cotton. Okay, but it is not very good for a construction. So we see what type of vegetation is present and what is the land use. Yes, once you go and visit your site, it what if that site is a dump yard? Okay, we what we people naturally do, if there is an open site, everybody puts a garbage there. Okay, so if it is going to be any dump yard for a municipal solid waste, or even it can be a dump yard for any industrial waste also, there could be huge piles of any ash or any other industrial effluents into your site. All those can contaminate your site and it can change the characteristic of the soil in that. So you just go and see your site. What is that site? What is it is being there for what purpose it was being used for a previous time, previous years. All those things you gather from your reconnaissance. Okay, so steps involved in preliminary subsurface investigation, so this we have answered. So reconnaissance, study of maps and aerial photographs. Okay, so the answer is going to be D. Dash is defined as the process of evolution of landforms. So any wild guess, you can give me a wild guess, no issue. Since it is options we have, choose the best.
D. Option D.
Option D, geomorphology. Okay, so geology is study of Earth in general. Structural geology is on how the stresses have acted on the rock or soil and how it has deformed. Petrology is on study of igneous, metamorphic, and sedimentary rocks. So geomorphology is defined as it gives it it is a study on process of evolution of the landforms. See, previously there could be a hill before some million of years ago, but now there could be no hill. Previously it could be underwater, now it has become a landform. Anything is possible. So answer is D. Guidelines regarding the depth of exploration and spacing of boreholes for dams. Can anyone tell me what is I-85878 1972?
Tunnel.
Huh? Tunnel. Okay, so it is
Tunnel.
5878 8. Okay, so I said double eight double n in a tunnel, and we have a 8 is like a tunnel kind of thing. So what could be the guidelines for dams? So it is is 6955 1973. This year is also not much important because it gets changed, but this number is important. At least you remember, try to remember this number. Why? Because in most of the interviews and everywhere in a written exams, they ask you, because this is one of like a challenging thing to remember. Okay, this is like only few people will be remember, they'll be able to easily filter the crowd. Okay, so at least you try to remember this number. So is 6955 is a codal provision for dams, and is 1892 is for multi-story building. Okay, that's what guidelines for depth of exploration for multi-story building is is 1892 1979. If you have any of your birthdays related, anything like that, okay, always the best thing to remember, I can tell you, or memorize. Okay, the best thing when you memorize any new name or a number, always connect it to whatever you know already. You know your birthday, you know your phone number, you know your roll number, register number. Okay, we have in our life, we remember lot of numbers already. Okay, try to connect possibly with this new number and with the what it means. Okay, it's like I am living in a multi-story building in a room number in a 18th floor, something like that. At least remember part of it. And I born in 1992. Okay, I born in 1992 in a 18th floor in a multi-story building. It's like a story. I have framed a story. Now this I will never forget in my life. I no need to keep on memorizing a number every time before I go to exam. Okay, we as a engineer we have to remember lot of guidelines, and again this is just a number in the guideline. Once you go into the guideline again, you will be having playing with the numbers again. Okay, it's just like for every 30 meter you have to give some 4 boreholes, 5 boreholes. If it is a multi-story building or a residential complex or a commercial building or hospital building, multi-purpose building is comes like that. Okay, so you will be able to remember only if you frame these kind of stories. This is how people will be able to clear competitive exams like gate or upsc. That is a one hint they use, I mean one tip they used to give. Okay, now if I even ask you what is a codal provision for multi-story building, can anyone tell what is a codal provision for multi-story building without seeing the number?
1892.
1892. Okay, at least something, at least you relate it to your age or anything. Okay, try to do that with all the formula, everything. You when you try to memorize in engineering, please connect it with a known thing. That is what, or make a story, make fun of it. Then you'll enjoy reading and you'll be enjoying to memorize them. Okay, so for multi-story building it is 1892 to 1979. So, which of the following is not classified as a detailed subsurface investigation? Detailed subsurface investigation. So, investigation of new projects, investigation to ensure safety of adjoining structure, investigation of defects or failures in case of existing structure, and investigation of groundwater table. So, once you go for a detailed subsurface investigation, and out of these, one is a preliminary investigation. So, which is that? It is investigation of groundwater table. So you have in preliminary investigation itself, you'll be able to find out or determine what is the ground, where is the groundwater table located. So that is not a part of detailed investigation, but we will be confirming it. We'll be confirming that. Okay, agencies involved in India that give information of subsoil from study of maps: BIS, Bureau of Indian Standard, Geological Survey of India, an international organization for standardization. So it is study of maps. Maps are prepared by Geological Survey of India. It's a easy thing. Okay, so they give you maps on type of rock, type of soil, type of mineral, everything. An isoseismal map. So when we are about to do a project in a seismic active zone, do you know how many zones are there? Do you know how many India has been divided to how many zones in terms of seismicity? Any idea? Anyone? Any number? I'm asking. India is divided into some number of zones in the ranging as seismically active to seismically inactive. Okay, as can anyone tell to how many zones the whole India has been divided? Any guess? Any rough number? Yes?
Five.
Huh? Five. Okay, very good. So India has been divided into 5 zones in terms of seismicity. So an isoseismal map is used to show the lines of equal seismic intensity. So it will be connecting the points of areas with seismic equal seismic intensity. That map we call it as a isoseismal map. There are no maps like connecting equal seismic hazard or magnet. This is a existing one. Okay, so dash is required to understand the suitability of site for the proposed project on basis of already existing information. So we do a preliminary investigation. That is what? From already existing information, we conduct a preliminary investigation in order to understand the suitability of our site. Guidelines for determining water table in boreholes. Yes. So IS 6935. for determining the water table in boreholes. Okay, so we have come to the end of the session. uh, do you have any doubts? Yes, yes. um, for whatever we have discussed today, do you have any doubts, any clarifications that you require from week one content? Try to attend all the assignments, because assignments have the very good weightage for your final ranking, whether you get a elite or a silver. Your assignments are very important. So does anybody have any doubt? Even if it's a no, you can put it in a chat box. So it's clear now. Hello.
ma'am.
Okay, so this is just week one session on emphasizing the importance of the site investigation. Why do we need to do it, and what are the outcomes that we get from a site investigation? Okay, and what are the stages involved in the site investigation, and what are the codal provisions for that? Okay, so if nobody has any doubt, shall I conclude the session? Okay, we'll leave now then. Thank you. If you have any doubt, you can post in the forum. Will I if if it's related to the content of that my lecture, I will just um, I will answer in the forum, whatever in that. Or if you have any doubt, you can also discuss in the session. Okay. Yes. Okay, thank you. Thank you all.